a feeling that just beyond our fragile blue atmosphere, events are unfolding that could challenge everything we think we know about the universe, and perhaps even ourselves. What if I told you that right now, a visitor from the depths of interstellar space is tearing through our solar system, and it's not just a chunk of ice and rock, it's a messenger, a puzzle box, an anomaly that is actively defying the fundamental laws of physics as we understand them. This is the story of an impossible transformation, a cosmic enigma that began on a night of celestial alignment and is now forcing us to question the very fabric of our cosmic neighborhood. This is the story of Comet 3I Atlas. Our story, a cosmic detective novel written in light and dust, begins on a truly special night, September 7th, as the Earth, Moon, and Sun aligned in a perfect, breathtaking lunar eclipse, casting our planet's shadow upon its celestial companion. Something truly extraordinary happened far out in the void. Comet 3I Atlas, an interstellar wanderer on its very first voyage into our solar system, underwent a transformation so profound, so impossible, that it sent shockwaves through the astronomical community. For months, as this visitor from another star system drew closer, our telescopes saw exactly what they expected to see. It possessed a dull, reddish hue. This color is like an ancient passport stamped with the chemical signatures of primordial compounds, the very building blocks of planets, leftover material from the dawn of some unknown, distant star. It was old, it was dusty, and it was, for all intents and purposes, behaving as a well-understood, albeit fascinating, interstellar comet should. But on that night, under the watchful gaze of our most powerful observatories, Atlas ripped up the rulebook. In a sudden, violent eruption of energy and light, its reddish coma, the hazy atmosphere surrounding its nucleus, blazed into a brilliant, almost supernatural emerald green. This isn't just a pretty color change. It's a fundamental clue in a cosmic mystery. That specific shade of green is the unmistakable, classic signature of a molecule called diatomic carbon, or C2. It's a fragile molecule, two carbon atoms bonded together, that can only exist in the near vacuum of space. When energized by the sun's ultraviolet radiation, it glows with this characteristic verdant light. Here's where the story takes its first sharp, inexplicable turn. This green glow is common in comets from our own solar system, especially as they get closer to the sun and heat up. But just 1 month prior to this spectacular outburst, the powerful spectroscopic eyes of the Kitt Peak Observatory in Arizona had performed a deep chemical analysis of Atlas. Spectroscopes are like chemical fingerprinting kits for astronomers. They break down the light from an object to see exactly what elements and molecules are present. The results from Kitt Peak were clear, unambiguous, and have since become the heart of this enigma. Diatomic carbon was virtually absent. It simply wasn't there in any significant quantity. So, we are faced with our first profound mystery, a question that cuts to the core of our understanding of cometary science. What switched on inside this alien object? How does a comet, in the blink of an astronomical eye, suddenly begin producing a chemical in vast quantities that, for all intents and purposes, it simply did not possess a few weeks earlier? It's like finding a sealed, ancient Egyptian tomb, confirming through every available test that there is no gold inside, only to have it spontaneously erupt from within, glowing and newly forged. It's a chemical impossibility, Was there a dormant process, a kind of cosmic hibernation that was suddenly awakened by a specific trigger as it crossed an invisible line in our solar system? Did a sudden, catastrophic event on its surface, perhaps a massive landslide of alien material, expose a completely new, previously hidden layer of its interior? Or are we witnessing a chemical reaction so foreign, so outside the bounds of our known astrochemistry, that we don't even have a name for it yet? This abrupt and fundamental change in its chemical makeup is more than just a scientific curiosity. It's the first clue that Comet Atlas is not just a passive visitor, it's an active, dynamic, and deeply mysterious entity, and its spectacular green transformation was only the opening act in a drama that would continue to unfold in ever more baffling ways. If the comet's impossible new color was the opening chapter of this cosmic mystery, its subsequent behavior began to add pages of pure, unadulterated paradox. In the world of astronomy, comets, especially those on their first trip into the inner solar system, are expected to follow a certain script. As they approach the sun, its energy heats their icy nucleus, causing gas and dust to sublimate, to turn directly from a solid into a gas. This process creates the coma and the tail, and it causes the comet to brighten. This brightening is usually a slow, steady, and most importantly, predictable process governed by well understood physical laws. Atlas, however, isn't just brightening, it's exploding in luminosity. It is surging in brightness far more rapidly, more violently, than any of our most sophisticated models predicted. The pattern of its light curve, the graph of its brightness over time, is utterly confounding for an object on its maiden voyage. It's not behaving like a dynamically new comet, a pristine relic from interstellar space, encountering a star for the first time. Instead, it's exhibiting a pattern more akin to what we call a dynamically old comet. Think of it this way: a dynamically new comet is like a tourist visiting a bustling hot city for the first time. They're cautious, their reaction to the new environment is gradual. A dynamically old comet, however, has been around the block. It has visited our sun many, many times before. Its surface is cracked, stressed, and volatile from thousands of years of being heated and cooled. It's like a seasoned traveler who knows exactly how the environment will affect them and reacts intensely and immediately. These old comets are known for their unpredictable and often dramatic outbursts in brightness. Atlas is behaving like that seasoned old traveler, yet we know for a fact, based on its trajectory, that it is a first-time visitor. This is a profound paradox. It is a celestial object with the passport of a newcomer, but the behavior of a long-time resident. How can this be? Is it possible that its journey through the interstellar medium was far more violent and aging than we thought? Could it have passed through the turbulent remnants of a supernova or close to another star, events that aged its surface prematurely before it ever reached us? Or does its composition, its very alien nature, mean that it simply doesn't play by the same rules as the comets born in our own solar system? It's a behavioral anomaly that suggests the physical structure and aging process of this object are fundamentally different from anything we have ever encountered. But even this baffling surge in brightness pales in comparison to what the Hubble Space Telescope discovered. When the most famous telescope in history turned its unparalleled eye toward Atlas, it revealed something so strange, so unprecedented. that astronomers are still struggling to find the words to describe it. It's a feature that has never, in the entire history of astronomy, been seen before. We all know what a comet is supposed to look like: a bright head and a long, glowing tail, or perhaps two tails, one of dust, one of ionized gas, stretching out behind it. The fundamental physics of this are simple and elegant. The stream of particles and radiation flowing out from the sun, known as the solar wind, acts like a celestial breeze, pushing the gas and dust of the coma away from the sun. No matter where the comet is in its orbit, its tail must always point away from the sun. It's a foundational rule, like gravity pulling an apple down. Hubble, however, saw something that defies this law. It saw a sunward extension of scattered light, an anti-tail. Let me be perfectly clear about what this means. Comet Atlas is projecting a faint but distinct plume of material directly toward the sun. This is the astronomical equivalent of a ship's wake appearing in front of the bow. It's like throwing a ball into the wind and watching it fly back into your hand. It's a direct defiance of the fundamental physics of radiation pressure. What could possibly be causing this? Is the comet ejecting particles with such ferocious velocity that they can momentarily overcome the force of the solar wind? Is there some bizarre electromagnetic interaction at play where the comet's own magnetic field is funneling charged particles in a direction they should not be able to go? Or are we seeing the light signature of a type of dust particle with such unique properties, perhaps in its shape, composition, or electrical charge, that it interacts with sunlight in a way we've never theorized? This anti-tail is not just an anomaly, it's a direct challenge to the laws we thought were universal. It's a ghostly finger pointing back at the very star that should be repelling it, a silent testament to the fact that out in the great darkness, there are still phenomena that lie far beyond our current comprehension. Together, the impossible color, the paradoxical brightness, and this physically defiant form paint a picture of an object that is not just alien in its origin, but alien in its very nature. As our telescopes peered deeper into the emerald green haze of Atlas's coma, the chemical enigma of this interstellar traveler only intensified, moving from the realm of the strange to the truly bizarre. The Very Large Telescope, or VLT, an array of 4 colossal telescopes nestled high in the arid mountains of Chile, focused its immense light-gathering power on the comet. What it found was a chemical cocktail so peculiar it has left astrochemists scrambling for explanations. The VLT detected a dramatic, almost unbelievable spike in the production of 2 specific substances, cyanide and nickel. Now, finding these in a comet isn't unusual in itself. Cyanide, CN, is a common cometary molecule, and nickel is a metal we expect to find in the dusty components of these cosmic icebergs. The anomaly, once again, was in the behavior. The rate at which Atlas was spewing out both cyanide and nickel was increasing at a staggering pace. This wasn't a gentle, linear increase. It was following an extreme power law with an exponent of 9. To put that into perspective, imagine you are filling a bathtub. A normal comet might be like turning on the faucet, with the water level rising at a steady rate. Atlas is like opening a fire hydrant connected to an ever-expanding reservoir. The rate of increase is itself increasing exponentially. An exponent of 9 is one of the steepest rates of chemical production ever measured in a comet, suggesting a process of sublimation and release that is almost explosively efficient, far beyond what our current models of solar heating can account for. But the real curiosity, the clue that points towards a truly alien origin, was in the nickel. In nature, as we know it, certain elements are cosmically married. They are forged together in the hearts of dying stars and are almost always found together in meteorites, asteroids, and comets throughout our solar system. Nickel's constant companion is iron. They are, in a cosmic sense, inseparable twins. Where you find a significant amount of vaporized nickel in a comet's coma, you should, without fail, find a corresponding amount of iron. The VLT found the nickel in abundance, but the iron was missing. The expected signature of iron was conspicuously absent. This is a signature that is incredibly uncommon in nature. It breaks the known rules of cosmic element distribution. However, this specific signature, plenty of nickel, but no iron, is seen in some highly specific, human-made industrial alloys. Now, no one is suggesting that Comet Atlas is an alien spacecraft, though its behavior certainly sparks the imagination. But what this chemical fingerprint does suggest is that the comet was formed in an environment with a chemical history and a set of physical conditions entirely different from those that gave birth to our own solar system. Perhaps it was born in a protoplanetary disk around a star that had a wildly different elemental composition. Or maybe it was formed in a region that had been seeded with heavy elements from a very specific and unusual type of stellar explosion. Whatever the cause, this nickel without iron signature is a powerful piece of evidence that Atlas is not just from out there, but from a place that might be fundamentally, chemically different from our own cosmic backyard. This idea of a foreign birthplace was cemented by the most powerful telescope ever built, the James Webb Space Telescope. Turning its incredibly sensitive infrared eyes to Atlas, Webb was able to analyze the dominant gases making up its coma, and what it found was the final confirmation of the comet's alien nature. In the comets native to our solar system, the coma is overwhelmingly dominated by water vapor, usually 80% or more, as the sun's heat sublimates the water ice that makes up the bulk of the nucleus. Webb found that the coma of Atlas is dominated by 87% carbon dioxide. Water is present, but it's a minor ingredient. This is a stark, dramatic reversal of the cometary recipe we are used to. A comet that is nearly 9/10 carbon dioxide ice suggests it was formed in a region of its home star system that was extraordinarily cold, far colder than the regions where our own comets formed. Water freezes at a relatively high temperature, but carbon dioxide requires much deeper cold to solidify into ice. This tells us that Atlas was likely born very far out from its parent star, in the frigid, dark outer reaches of its system. It is a true child of the interstellar deep freeze. This puzzling chemical cocktail, the sudden appearance of diatomic carbon, the extreme production of cyanide, the strange nickel-iron imbalance, and the overwhelming dominance of carbon dioxide all combine to tell a single, coherent story. Comet Atlas is a messenger from a place that operates under a different set of rules, a place whose history is written in a chemical language we are only just beginning to learn how to read. In the midst of this incredible period of scientific discovery, as astronomers around the world collaborated to unravel the genuine mysteries of Comet Atlas, a very different kind of phenomenon was brewing here on Earth. A storm of misinformation, fueled by the rapid-fire nature of social media, began to rage. A viral narrative built on misunderstanding and sensationalism took hold, centered on the terrifying claim that there wasn't just one comet, but a second, even larger one, hurtling towards us on a collision course. This narrative is a textbook case of mistaken identity, a fiction born from the conflation of two completely separate and distinct astronomical events. The second comet in these viral posts is a real object, Comet C2014 UN271, more famously known as Bernardinelli-Bernstein. And in one respect, the claims are true. It is absolutely colossal. Discovered in 2014 in archival data, Comet Bernardinelli-Bernstein is one of the largest comets ever observed. Its nucleus, its solid core of ice and rock, is estimated to be around 140 kilometers, or about 85 miles wide. To give you a sense of scale, that's nearly 10 times wider than the comet that likely caused the extinction of the dinosaurs. It is a true giant, a mountain of primordial ice, lumbering in from the most distant reaches of our own solar system, the Oort cloud. However, that's where the truth in these sensationalist claims ends. Comet Bernardinelli-Bernstein is not a new discovery, and most importantly, it poses absolutely zero threat to Earth. It is on a long, slow journey that will take thousands of years to complete. Its closest approach to the Sun, its perihelion, won't occur until the year 2031, and even at that closest point, it will remain safely beyond the orbit of Saturn, hundreds of millions of miles away from us. It will never come anywhere near the inner solar system or pose any danger to our planet. The misinformation storm arose from a simple but dangerous confusion. People saw the genuine scientific excitement and headlines about the interstellar visitor, Comet Atlas, and its bizarre behavior. At the same time, they saw older, but equally amazing, news about the gigantic size of Comet Bernardinelli-Bernstein. In the echo chamber of the internet, these two separate stories were mashed together into one terrifying but completely false narrative. The giant comet is the interstellar one, and it's coming for us. This situation serves as a powerful, real-world lesson in the importance of critical thinking and media literacy. The universe is genuinely filled with awe-inspiring and sometimes perplexing wonders. The story of Atlas is a perfect example. The truth is often more fascinating, more complex, and more beautiful than any fiction we could invent. But it's our responsibility, as consumers of information, to be discerning. We must learn to check sources, to differentiate between the careful, peer-reviewed findings of the scientific community and the baseless, fear-mongering claims of anonymous accounts online. The second comet misconception is a distraction from the real, incredible story that is unfolding. While a fictional threat was causing panic, the global scientific community was busy coordinating one of the most ambitious observational campaigns in recent history, preparing to unlock the very real secrets of our one true and very mysterious interstellar guest. As Comet Atlas barrels through the heart of our solar system, the clock is ticking. The coming weeks are absolutely crucial in our quest to understand this enigmatic visitor. We are entering a unique window of opportunity, a period where our robotic eyes and ears, stationed across the solar system, can get an unprecedented close-up look. This is no longer just a mission for ground-based telescopes. We are calling in our interplanetary emissaries, The first major rendezvous is set for October 3rd. On this day, Atlas will make its closest approach to the planet Mars. This is an incredible stroke of cosmic luck. It means that two of our most sophisticated Martian orbiters, the European Space Agency's Mars Express and the ExoMars Trace gas orbiter, will have a front row seat to the spectacle. From their vantage point orbiting the red planet, they will be able to perform a close-up analysis of the comet during what is expected to be its peak period of activity and brightness. These spacecraft are not just equipped with cameras. They carry advanced spectrographs, instruments specifically designed to dissect the light from an object and reveal its chemical composition in exquisite detail. They will be able to analyze the gases in Atlas-Coma with a precision that is simply impossible to achieve from Earth, millions of miles away. They may hold the key to solving this central mystery, the origin of the brilliant green glow of diatomic carbon. Was it really absent before, or was it simply hidden? What process is creating it in such vast quantities? These Martian probes, our sentinels at the fourth planet, might just give us the answers. Then, later, in November, another of our deep space explorers will get its chance to study the comet. ESA's Jupiter, Icy Moons Explorer, known as JUICE, is currently on its long and winding journey to the Jovian system. As Atlas begins its long trip back out of the solar system, its trajectory will give the JUICE spacecraft a unique perspective. It will be able to observe the comet from a different angle, a vantage point that can reveal new information about the structure of its tails and the way it scatters sunlight. However, this ambitious, system-wide observation campaign is not without its challenges. This is not like sending a command to a satellite orbiting Earth and getting an answer back in seconds. This is deep space, where the distances are vast and the timescales are immense. The data collected by the orbiters at Mars will take precious minutes to travel back to Earth, and the data from the JUICE mission, which will be much farther out, faces an even longer journey. Because of the spacecraft's location and the complexities of deep space communication, the precious information it gathers in November may not even reach the anxious scientists back on Earth until sometime in 2026. It's a powerful reminder of the patience and perseverance required for space exploration. We are sending our robotic proxies out into the void to witness these fleeting cosmic events for us. They will gather the data, but we must wait, sometimes for years, for the full story to be transmitted back, one packet of data at a time, across the immense, silent gulf of space. These missions represent our best, and perhaps our only, chance to truly get to grips with the mysteries of Atlas before it disappears back into the interstellar night forever. As October progresses, Comet Atlas will approach the climax of its incredible journey, the single most important moment in its brief, fiery visit to our solar system. It will reach perihelion, its closest approach to the sun. This is the moment of maximum drama, the point where the sun's immense energy, its searing heat, and powerful radiation will have its greatest effect on the comet's alien nucleus. This is the moment when its secrets are most likely to be revealed. Under this intense solar bombardment, hidden pockets of volatile gases could erupt from the surface. The mysterious processes driving its extreme brightening and chemical production will be pushed to their absolute limit. We could see the nucleus itself fracture or break apart, revealing its pristine, interstellar interior for the first time. the sunward antitail might flare up, giving us crucial clues to its impossible physics. Perihelion is the climax of the story, the final act where the protagonist faces their greatest trial, and we are going to miss it in a moment of profound, almost cruel, cosmic irony. At the exact time that Comet Atlas is at its most active, its most revealing, it will be on the opposite side of the sun from Earth. Our planet and the comet will be in a configuration known as conjunction. The sun, the very object causing the dramatic display, will be directly in our line of sight, completely blinding us to the event. Our planet-bound telescopes, even our most powerful ones, will be utterly useless. It's like having tickets to the greatest show in the universe, only to have the curtains fall just as the main event begins. This frustrating timing means we must place our trust, our hopes for understanding this object, entirely in the hands of our robotic observers scattered across the solar system. We will be like anxious parents waiting outside a locked room, relying on the accounts of others to tell us what is happening inside. Our orbiters at Mars will have already had their close look. Now, our hopes will ride with some of our most daring and resilient probes, like the Parker Solar Probe. This incredible spacecraft, on its mission to touch the sun, will be in a unique position. As it endures the sun's blistering corona, its instruments might just be able to catch a glimpse of Atlas as it endures its own trial by fire. Following this unseen climax, after it has survived its perilous passage around our star, Atlas will begin its long, outbound journey. It will fade back into the cold and the dark, starting its trip back to the vast, empty spaces between the stars from whence it came. It will be forever changed by its encounter with our sun, its surface scarred and its chemistry altered, and it will leave us, its temporary observers, with a legacy. That legacy will be a mountain of data, a collection of perplexing clues transmitted from our robotic envoys across the solar system. The story of Atlas will not end at perihelion. In a way, that's where the real work will begin. For years, even decades to come, scientists will be poring over the spectrographic readings, the images, and the light curves. They will build new models, write new theories, and debate the meaning of the nickel without iron, the sunward anti-tail, and the impossible green glow. This single, fleeting visit from a lone interstellar wanderer will reshape our understanding of these cosmic messengers. It will force us to reconsider how comets are formed, how they evolve, and what diverse chemical environments exist out there in the galaxy. Atlas serves as a humbling reminder that the universe is far stranger and far more wonderful than we can possibly imagine. The story of Comet Atlas is more than just a fascinating astronomical event. It's a mirror, reflecting some profound truths about our own lives, our own journey through the universe. First, it teaches us the profound importance of questioning our assumptions. For centuries, we had a neat, well-ordered understanding of how a comet should behave. Atlas shattered that. It reminds us that no matter how much we think we know, the universe always holds the capacity to surprise us. In our own lives, how often do we operate on a set of fixed beliefs about ourselves, about others, about what is and isn't possible? This comet challenges us to look at our own rules and ask, are they really laws of nature or just the current limits of our understanding? True growth, both scientifically and personally, begins the moment we are brave enough to say, I don't know, and embrace the mystery. Second, the story of the second comet misconception is a powerful lesson for our modern age. In a world saturated with information, the ability to discern truth from fiction is not just a skill, it's a survival mechanism. We must approach information with a healthy skepticism, seek out credible sources, and resist the allure of easy, sensationalist answers. The real universe, as Atlas shows us, is mysterious enough without us needing to invent new fears. The truth is always worth the effort of finding it. And finally, consider that frustrating, unseen climax. The most important moment in the comet's journey will happen when we can't even watch. It's a beautiful metaphor for life. So many of the most pivotal, transformative moments in our own lives happen quietly, internally, when no one is watching. They are the moments of quiet decision, of unseen struggle, of a solitary change of heart. We don't always need an audience for our growth to be profound. Like the scientists relying on their distant probes, we must learn to trust the process, even when we can't see the outcome directly. We must gather our data, be patient, and have faith that the story will reveal itself in time. The legacy of Atlas is a call to curiosity, a call to critical thinking, and a call to embrace the beautiful, humbling uncertainty of it all. It reminds us that we are part of a story so vast and magnificent that we will never run out of new chapters to explore. And now, I have a few questions for you. What part of this cosmic mystery fascinates you the most? Do you think we will ever find a simple explanation for the comet's bizarre behavior? Or is it a sign of truly alien physics we have yet to discover? And what lessons do you take away from this incredible story? Let me know your thoughts in the comments below. I read every single one. Thank you so much for joining me on this journey to the edge of our understanding. I wish you all good health, clear skies, and a life filled with curiosity and wonder. And if you enjoyed exploring this mystery with me, please consider subscribing and hitting that notification bell. There's a whole universe of stories out there waiting to be told.